Yes. Dear students, welcome to Race Academy Bangalore's solution for R1 code 73 to 85. 73 question. A compound with a molecular formula 14 has the two carbon atoms. The UPAC name of this one. See, if you are taking the 6 carbons like this, adjacent carbons, if you take 2 comma 2 dimethyl. So if you take 1, 2 like this, okay, 2 comma 2 dimethyl butanes, then you will get the answer. If you are cancelling the remaining, see, if you just take 2 comma 2 dimethyl butane, compound has molecular formula C6H14 is there. Two tertiary carbons are present. Where? I'll show you. And this is one tertiary carbon. So second option is the right option for this one. Next question. Henry's law constant value of three gases given A given 10 power 145. A is 145, whereas B is 2 into 10 power minus 5. C is the 35 kilobar. 35 kilobar. So carefully observe Henry's law constant and solubility, how they are relation. Henry's law constant and solubility are inversely proportional. So in this, which one is a small one that has greater solubility? So that means B is a greater solubility than C than A. First option is the right option for this one. Next question, the compound that will undergo SN1 reaction with a faster rate, as we all know, S1 reaction is faster when we have secondary and tertiary carbocations are generating in that one. So okay, we have secondary alkyl halide given is that is also that to benzyl, that is a greater stable we have in this one. So C is the right option. Next thing, the most stable carbocation among the following is here. Also same thing again, carbocation discussion only, like 75. Here this is also carbocation. Tertiary carbocation is more stable because of the different factors of electronic effects and all, like hyperconjugation and all these things. So then we can count the number of hyperconjugated structures are more for this one. That is more stable. So third one is the right option for this one. Next, given below are the two statements. We have statement when both cobalt, hexaamine cobalt 3 and hexafluorocobalt 3 minus complexes are 3 are octahedral but differ in their magnetic behavior. That is true. Why? Because NH3 is a strong field ligand, F minus is weak field ligand. Statement 2, and hexaamine cobalt 3 is a diamagnetic, where this one is paramagnetic. This is very true because we have strong field ligands are the inner orbital complex will be formed. So rearrangement gives unpaired electron number 0 in cobalt ammonia complex, whereas cobalt fluoride complex we have unpaired electrons are positive with weak field ligand higher. That is nothing but high spin complexes. So both are true. Statement 1 and statement 2 both are true. Next question, 1 gram of sodium hydroxide was treated with 25 ml of 0.75 HCl solution. The mass of sodium hydroxide left unreacted is equals to, see, first we have to see the equation part. When the equation is given like this, we have NaCl, NaOH, HCl. So HCl millimoles equals to NaOH millimoles. We have calculated the millimoles of HCl, that is 25 and 0.75 moles, that is become 18.75 millimoles of HCl came. The same millimoles of sodium hydroxide is there. That means how much sodium hydroxide is reacted with HCl means yes, that is about 750 milligrams of this sodium hydroxide is reacted with HCl. It means that unreacted sodium hydroxide is how much out of 1 gram. So 1 gram means 1000 milligrams, and if you subtract this 750 milligrams which is already reacted with this one, then you will get 250 milligrams. So 250 milligrams is the right answer. Next question, given below are the two statements. We have the boiling point of hydrates of group 16 elements follow the order. We have H2O greater than H2D, H2SE, H2S given there. This is correct only. Why? Because water's hydrogen bonding is one of the most important factor. On the base of molar masses also, actually H2O is expected to have lower boiling point, but the number of group numbers of the group we have due to the presence of extensive hydrogen bonding in water, it has higher boiling point. So although hydrogen has lower molar mass, it is exhibiting this one is higher boiling point because of this one extensive hydrogen bonding. So both the statement and statement 2 both are correct. Next one, arrange the following elements in the increasing order of the first ionization enthalpy. So left to right in any period the size decreases. At the same time the stable electronic configurations completely filled and half filled configurations of beryllium and nitrogen, if you consider lithium less than boron less than beryllium less than carbon less than nitrogen will come. Little uneven irregular arrangement, only boron and beryllium we will see because of beryllium stable electronic configuration, nitrogen stable electronic configuration. So first one is the right option in this one. Next question, arrange the following elements in the increasing order of electronegativity. So electronegativity for fluorine is highest, we know. We have first one and last one if you have then there is will be a oxygen nitrogen electronegativity case, and which is fourth one is the right option for this one. Next question, activation energy of the chemical reaction can be calculated by two. If one knows the value of rate constant of two different temperatures, we know what is that activation energy k1 by k2 and all these things. If you just calculate, and this we will calculate logarithmic form. When we calculate, when we have two answers are there, what are the answers? Temperature answers T1 and T2, that is the EA by 2.303 R into T2 minus T1 by T1 T2. We know this formula. So this is one of the important things, the rate constant at two different temperatures. If you know, then you can calculate activation energy easily. Next question, 82 question. Next question, that is quantum numbers given in the list 1 and list 2. We have shapes of given, we have information given. That is the first one ml given, that is magnetic quantum number. Magnetic quantum number is actually related to the orientation of the orbital. ms that is the spin quantum number is orientation of spin, whereas l is the orbital quantum number is shape of the orbital, and n is the size of the orbital. So if you just check all these things, first one is right option A3 B4 C1 D1 D2 will come. Next one, ammonia given here, list 1 given, list 2 given. Here also geometries from the chemical bonding chapter asked. Ammonia is a trigonal pyramidal, and SF6 is octahedral, BRF5 is square pyramidal, XCF4 is square planar. So it is matches with A1, B4, C2 and D3. Fourth option, right option for this one. Next question, the plot of ln K versus 1 by T is consistent with the Arrhenius equation. So which of this the one is correct equation? So Arrhenius equation, if you observe K is equal to A into e to the power of minus EA by RT. Logarithmic form, if you apply ln K is equal to minus EA by R, slope is negative. That is matches with the third option. So that is the right answer. So these are the answers from 73 to 85 we discussed in this session. Thank you very much. We'll meet in a video for the next rest of section B questions and all. Thank you very much from our end, Race Academy Bangalore. Thank you.